Hello everyone. Today we're going to discuss how to condense a log expression using the three properties discussed earlier in those videos. So if we scroll down, we have a few problems here. We saw this exponential property of logs before. Anytime you have an exponent, that could become a coefficient, and that goes vice versa. So anytime I have a coefficient, I can write it as an exponent. So if you take a look at number one, I have 10 times the log base 5 of x. So if I do this, oops, sorry about that. So if I do this, that coefficient of 10 can be written not as a coefficient, but as an exponent on x. So it would be log base 5 of x to the 10th, okay? And that would be my final answer. That's all. That would be the property that I would have to use for this particular question. So I have a second example, right? So if I have a coefficient of 5, right, that coefficient is going to become my exponent. So now it's going to be log base 6 of 2 to the 5th. And if you really wanted to reduce this, you could call this a log base 6, and 2 to the 5th power is 32, and that would be the same answer as well. I would accept either one of those responses as correct. Okay? All right. So that's the first property. If you have a coefficient, it becomes an exponent. All right. The next one is if you have a sum of two logs here in blue. If you have a sum of two logs, that's going to be a product. So if we have two separate logs, we can put them together as a product of two things. So in this case, you can see I have the log base 3 of 2. I have the log base 3 of x. They are being added together. So this can ultimately be just written as the log base 3 of 2x. Okay, so anytime you have a sum, that can be written as a product. All right, so we're just condensing them down into one log. All right, so here I have just a sum of three things. So we're going to condense them down. I'm going to start with just two at a time. So if I take the first two and I put this in there, this would just be 5r plus the log of s. Now, if I multiply 5r times s, that ultimately just becomes 5 times r times s, all inside the log. Again, I have one log expression with all of the pieces inside, okay? And since they're added, we multiply them together. So that's the second property. Anytime you're adding two logs, we can multiply their insides together, okay? And then the last property was subtraction, right? So if we subtract two logs, then it becomes division. So if I take the log base 7 of 3 minus the log base 7 of x, this is going to be the log base 7 of, the first one is always the numerator, and the second one is always the denominator. So it would be 3 over x, okay? So anytime you have subtraction, that becomes division. So again, I have a natural log here. So y over z, and that would be my final answer. Okay. Now, what I want to do is I really want to practice trying to put all the pieces together. What happens if I have multiple properties in one problem, right? How do I go about doing that? And when I do this, I usually start, if there's any exponents, I do that first. Okay. I raise anything to a power that needs to be raised, and then I start piecing things together appropriately. Okay, so let's take a look at number one. So I have this exponent of 2. I know that's got to be, or that coefficient of 2, I know that's got to be an exponent. So I'm going to say log base 7 of 5 plus the log base 7 of x squared. Okay, now that 2 is only a coefficient on the second log, so that's the only thing that gets the exponent. So we do that first. Then you can see that I have a sum of two logs. So when I put these together, I'm going to have the log base 7 of 5 times x squared. And that would be my final answer. Okay, so let's take a look at number 2. So I don't have any coefficients, so there aren't any exponents that need to be had here, but I am going to combine these together. I'm going to say the log of 3x, because they're being added, I know I can multiply them, minus the log of y. Now, so addition turns into multiplication. Subtraction is going to turn into this division. So I'm going to say the log of 3x, that would be in the numerator, and then the y would be in the denominator. And then that would be my final answer. Okay, So you can kind of see all these properties in at play, and we're going to need some practice, which I have 2 more here to do, and then I have an assignment for you to do some on your own. So again, first step, I look for exponents, see if I have any exponents. I do. So this 4 would be an exponent. This 9 would become an exponent. So I'm going to have the ln of 5 plus the ln of x to the 4th plus the ln of y to the 9th. Okay, and now I'm just going to kind of piece 2 together at a time. The ln of 5, and because it's plus, we're going to multiply, right? And you can see that I have another log or natural log added. So I need to multiply again. So 5x to the 4th times y to the 9th. And then that would be my final answer. Okay. Now, last problem. So again, anything that's a coefficient becomes an exponent. Okay. I'm going to say the log of 6 minus the log of x squared minus the log of y to the 5th. Okay, so I get rid of those coefficients first. Now I piece 2 things together at a time. So I have a subtraction here. So I'm going to say the log of 6 over x squared minus the log of y to the 5th. Now I have a second piece that's going to be divided. And really all that means is that it's going to go into the denominator. If I put these together, I'm going to have the log of 6 divided by x squared, and it's got to be divided by a y to the 5th. So if you have 2 things that are subtracted, then both of those arguments are going to be in the denominator of your answer. And that's where I get my answer from. Okay, there are 4 problems for you guys to do on the assignment. Try to get those done. Let me know if you have any questions, and hopefully this video helped you all out.